This video, we're going to prove that if the summation of a sub n and then goes from 1 to infinity converges, then a sub n goes to 0. In this type of a problem, I would think it would be better to prove the contrapositive, which is exactly the same statement. It's logically the same. Basically, it says if not this, then not that. So if not an goes to 0, that means if an does not go to 0, then the summation as n goes from 1 to infinity of a sub n does not converge. That means it diverges. Proving this is exactly the same proof. And we're going to do this by cases. Assume that a sub n goes to k, where k is greater than 0. I'm not going to prove the case where k is less than 0. It's going to be very similar. Case 1. Okay, so k is not 0, but it's positive. And we want to prove that the summation diverges. So exactly what does this mean? This means, so a sub n approaching k is the same as, given any epsilon greater than 0, there exists a capital N in the natural numbers such that whenever n is bigger than capital N, we always have that a sub n minus k is less than epsilon. Now, let us look at this a little bit more closely. This says that a sub n minus k is in between negative epsilon and epsilon. This is the same statement as above, which is the same statement as k minus epsilon is less than a sub n, which is less than k plus epsilon. Now, I want to get a lower bound for a sub n. I want to get a lower bound for a sub n. So how about, just want to see one more thing. How about, yeah, fine. How about we let epsilon equal half for k. Now remember, we're supposed to be able to find an n given any epsilon. So now what we have is the following. Plugging in epsilon, we get that a sub n is bigger than k over 2 minus epsilon. Oh no, just k over 2, which is less than a sub n, which is less than, to be honest, what I don't care about. I just care that ANs are bigger than k over 2. Whenever n is bigger than capital N. Okay, so let's just consider the summation as n goes from big N to infinity of a sub n. This is going to be bigger than the summation as little n goes from big N to infinity of k over 2. But that's infinity. If you keep adding up k over 2 from some number to infinity, k over 2 plus k over 2 plus k over 2, it doesn't matter how large n is. It can be 1, it can be 10 billion. But you're going to infinity. K over 2 plus k over 2 plus k over 2. This positive number repeatedly being added to itself is going to approach infinity. Okay, so what we have is that this is bigger than something that equals infinity. Therefore, for this case, the summation, okay, now let's just say this. The summation as 1 goes to n, as n goes to infinity, as n goes to infinity of a sub n, well, this is equal to summation as n goes from 1 to n minus 1 of a sub n. This is finite. You add up n minus 1 numbers, you're going to get an exact answer. 74, 98. It's not going to diverge. It's not going to approach 17 or negative 4. It's going to be an exact amount. Plus, so this is finite. Plus, the summation as n goes from capital N to infinity of a sub n. Well, as we just showed you, this part is infinite. And when you add an infinite number to finite number, it diverges to infinity. So it diverges. Now we want to show that if an doesn't go to 0, then a sub n diverges. Okay, what about case number 2? An does not go to 0, but a sub n does not approach any one value. For example, if the sequence a sub n was 1 minus 1 plus 1 minus 1 forever and ever, well, this keeps oscillating between, let's see, 0 and then 1, and then 0, and then all the way up to here 1, and up to there 0, and then add 1. So it's oscillating between 0 and 1. Okay, and I don't know what to say about this case yet. It doesn't approach any one value. So it does not. So it diverges. So it diverges. If it doesn't approach a unique value, it diverges. Proof is done. Okay? If a sub n converges, then a sub n must go to 0. Now, I guess I rarely should say this. Okay, so if it converges, that implies that a sub n goes to 0. Okay, If the summation of a sub n converges, that means a sub n goes to 0. It does not say if an goes to 0, that implies the summation converges. It does not say that. I'll leave it to you to think about that. Leave a comment about it. Tell me that you don't understand. Tell me that it's obvious. Tell me how much you dislike this proof. Tell me how much you like the proof. Tell me a different proof. Tell me which step I could have done the proof better. Tell me how much you didn't like the proof. And most of all, if you have a theorem that you would like for me to prove, we'll put that in the comment section and I'll probably do it. Most importantly, watch and learn.